construct a Born-Haber cycle for magnesium chloride and use it to determine the magnesium to chlorine bond energy from the given information below. We have been given atomization enthalpy of magnesium, atomization enthalpy of chlorine, first ionization enthalpy of magnesium, second ionization enthalpy of magnesium, electron affinity of chlorine, and enthalpy of formation of magnesium chloride. We have been asked to determine the magnesium to chlorine bond energy. There is a relationship between sum of the bond energies and lattice energy. Sum of the bond energies, or in other words, sum of the bond energies is called lattice dissociation energy and lattice energy. Lattice energy is the heat energy which is released to the surroundings when 1 mole of ionic compound is formed from the combination of its corresponding gaseous ions. So it is a negative enthalpy change. It is negative enthalpy change. So, but the sum of the bond energies is positive value. It is positive value. So, sum of the bond energies or lattice dissociation enthalpy or energy is equal to the absolute value of the lattice energy. Now we have to determine first the lattice energy. Lattice energy and sum of the bond dissociation energy, they are equal in magnitude but opposite in sign. So we have to determine first the lattice energy, and then we use it to determine the sum of the bond energies. Now the Born-Haber cycle is drawn from down upward. So we have to write the elements which are reacting to form the compound which is magnesium chloride. Now this is magnesium element. This is metallic element. It exists in solid form. And plus chlorine. This is a non-metallic element which exists in gaseous form. Now, then after writing the elements in their normal physical states, you have to take a ruler, then draw a horizontal straight line, indicating that these standard substances, these reacting elements are in the same energy level. The elements in their normal physical state have heat of formation which is equal to 0. Now, heat of formation of magnesium is 0, while the heat of formation of chlorine is 0. Now then after that, after writing that equation, we have to rewrite the equation on rough paper. Go to rough paper and write the equation, the reacting to form magnesium chloride. But the valency of magnesium is 2, while the valence of chlorine is 1. So when they are combining is 1. So when they are combining, they tend to exchange their valencies. The valency of magnesium is written as a subscript of chlorine, while the valence of chlorine is written as a subscript of magnesium, but 1 is not written. Now the product formed is magnesium chloride. Then after that, we have to balance the reaction equation. But when you are balancing the reaction equation, you have to know that the product formed must be 1 mole. Why? Because because the Born-Haber cycle is drawn to determine the lattice energy for 1 mole of ionic compound. So to balance in such a way that the product formed must be 1 mole. Now this is 1 mole, 1 magnesium, 1 magnesium, 2 chlorine atoms, 2 chlorine atoms. It has balanced. Now, since it has balanced, some of the students and teachers tend to confuse. They tend to write the product form at the end of this horizontal line. You are not allowed to write the product form at the end of the horizontal straight line. Why? Because this indicates that the product form and the reactants are in the same energy level. So that is not correct. That is not true. Why? The product formed has a heat of formation which is not equal to 0. This one. But these have heat of formation which is equal to 0. They are standard substances. So you are not allowed to write the product at the end of this horizontal straight line. Then after that, we have to, these elements cannot react because they have very low amount of heat of formation, which is 0. So in order for them to react, they have to absorb a series of heat energy from environment. Now, let's start with the metallic element. We have to deal first with the metallic element until it has reached an extent to react. Then, after reaching an extent to react, we shift to the non-metallic element. So, magnesium absorbs the first amount of heat energy, which is called the atomization energy. Magnesium element is atomized to form magnesium gas pass, gaseous form pass. Chlorine. Then after that, you have to draw a horizontal straight line to indicate that these chemical species are in gaseous, are in the same energy level. Then after that, magnesium has not reached an extent to react. In order for it to reach an extent to react, it must absorb other amount of heat energy, resulting to lose 2 electrons. Then after it has lost 2 electrons, it reaches an extent to react. So before that, this is atomization energy of magnesium, which is equal to positive 148 kilojoules per mole. Then after that, magnesium loses 2 electrons, but the 2 electrons are not lost at once. They are lost in series. I mean in steps. They are lost in steps. In the first step, the first electron is lost. The first electron is lost to form the monopositively charged gaseous ions. First electron is lost. This is a gas. Then after that, you have to draw a horizontal straight line to indicate that the chemical species are in the same energy level. Then this is a first ionization energy. First ionization energy, I mean a first ionization energy. First ionization energy of magnesium, which is equal to positive 736 kilojoules per mole. Then after that, magnesium has not reached an extent to react, so it absorbs another amount of heat energy, which is called the second ionization energy, which results to lose the second electron plus chlorine. This is a gas. You have to draw a horizontal straight line indicating the chemical species are in the same energy level. But this is the second ionization energy. Second ionization energy of magnesium, which is equal to second ionization energy of magnesium, which is equal to positive 1450 kilojoules per mole. Then magnesium has reached an extent to react. Since it has reached an extent to react, don't draw an arrow. at this point. It has reached an extent to react. Then after that, we have to shift to the non-metallic element, which is chlorine. Now, chlorine absorbs a certain amount of heat energy called dissociation energy. Now, this is dissociation energy. Dissociation energy to form 2 moles of chlorine atoms. 2 moles of chlorine, 2 moles of chlorine atoms. Magnesium, this is a gas. Then after that, we have to draw a horizontal straight line. Horizontal straight line indicating that the chemical species are in the same energy level. This is a dissociation energy. But we have been given atomization enthalpy or atomization energy of chlorine, which is equal to this one. But we have to know that there is a relationship between atomization energy and the dissociation energy. Atomization energy and dissociation energy. The energy which is used here is the dissociation energy and not the atomization energy like the energy which we have been given. What is the dissociation energy? Dissociation energy is the heat energy required to break down 1 mole of an element which exists in molecular form to form the corresponding gaseous atoms. So, if the element is diatomic, if the element exists in diatomic form, like chlorine, when 1 mole of the diatomic element is dissociated, it forms 2 moles of corresponding gaseous atoms. So there is a relationship between atomization energy and dissociation energy. When atomization energy is equal to dissociation energy. What is atomization energy? Atomization energy is the heat energy required to break down an element in its normal physical state to form 1 mole of corresponding gaseous ions. So, in order to determine the dissociation energy, we have to multiply the atomization energy of chlorine given by 2. So, atomization energy of chlorine is positive 2. Is 2 times positive 2. I mean 1 to 1. This is kilojoules. This is kilojoules. Kilojoules, not per mole because there are 2 moles. Kilojoules. Then after that, chlorine has not reached an extent to react. In order for it to reach an extent to react, it must gain or accept the electrons lost by magnesium. There are 2 moles of chlorine. Each mole of chlorine, 1 mole of chlorine atoms accept 1 mole of electrons. So there are 2 moles. So this 1 mole of electrons is gained or accepted by the 1 mole of chlorine. And this 1 mole of electrons is gained by the other mole of chlorine atoms. Now, the 2 moles of electrons are gained by the 2 moles of chlorine, but electrons are being accepted by the neutral gaseous atoms for the first time. First addition of electrons to the gaseous atoms is to the neutral gaseous atoms is an exothermic process. Heat energy is released to the surroundings. Why? This is because the electrons are being attracted by the nuclear attractive pull of those neutral gaseous atoms. There is no repulsive force. Now, then heat energy is released to the surroundings. So the arrow should point downward. Why? Because it's the heat energy released to the surroundings. The heat energy absorbed from environment are shown by arrows which are pointing upward. So the arrows pointing upward indicate the energy absorbed from environment, showing that energy is increasing. But the arrows pointing downward shows that energy is being released to the surroundings, and the energy is decreasing. Now this is 2 times the electron affinity of chlorine, 2 times the electron affinity of chlorine, which is equal to 2 times negative 364 kilojoules. Negative 364 kilojoules, not per mole, because there are 2 moles. Now this is chlorine, negatively charged, plus magnesium, gaseous ions, Now, these chemical species, now chloride ions have reached an extent to react, and magnesium ions have reached an extent to react. So they are combined. So at this point, they tend to combine. But when they are combining together, they tend to form an ionic compound. During formation of ionic compound, or during combination of the corresponding gaseous ions to form the corresponding ionic compound, is an exothermic process. Heat energy is released to the surroundings. So that amount, the amount of heat energy released to the surroundings is called lattice energy. It is called lattice energy. It is called lattice energy. Now, lattice energy of magnesium chloride. Now, since it is the heat energy released to the surroundings, its arrow should point downward. So we don't know where the product, which is magnesium chloride, where it is formed. We don't know where it is formed, whether above this horizontal line or below this horizontal line. So in order for us to know where the product is formed, we have to look at we have to consider the enthalpy of formation of magnesium chloride. The heat of formation is negative. So since the heat of formation is negative, the product is formed below this horizontal line. This horizontal line indicates the enthalpy of formation of the reacting elements. These are standard substances. Since they are standard substances, the enthalpy of formation is 0. So since it is 0, this represents 0 heat energy. Now, N number below 0 is negative. N number above 0 is positive. So since the heat of formation is negative, the product is formed below. This is 0 line. Now, magnesium, this is magnesium chloride is formed with this. This is a solid. Then after that, we have to take a ruler and then draw a horizontal, a straight line. Then after that, the heat energy released to the surroundings. The heat energy released to the energy difference between the energies of the reactant and the energy of product is called the enthalpy of formation or heat of formation. Now, heat of formation of magnesium chloride is equal to negative 641 kilojoules per mole. Negative 641 kilojoules per mole. Then after that, from Hess's law, this is the first root. Root 1. While this one is root 2. This is root 2. The first root is from the reactant all the way to the product. But the second root is from this point. This root, this root, this root, this root, up to this point is the second root. Now from Hell's law, we are going to determine the lattice CNH. From Hell's law, from Hell's law, enthalpy change in root 1 is equal to total enthalpy change in root 2. So, but enthalpy change in root 1 is the enthalpy of formation of magnesium chloride. So, enthalpy of formation of magnesium chloride is equal to atomization energy of magnesium, plus first ionization energy of magnesium plus second ionization energy of magnesium plus dissociation 2 times atomization energy of chlorine, which is dissociation energy of chlorine, plus 2 times electron affinity of chlorine plus lattice energy of magnesium chloride. Then after that, this is equal. This enthalpy formation of this is negative 641 kilojoules per mole. This is equal to atomization energy of of magnesium is positive 148 plus first ionization energy of magnesium is positive 736 kilojoules per mole plus second ionization energy which is positive 1450 plus dissociation energy 2 atomization energy 2 times atomization energy of 1 to 1 positive plus of chlorine plus 2 electron affinity of chlorine which is negative 364 plus lattice energy now of magnesium chloride. Now answer is positive 1848 plus lattice energy of magnesium chloride. This is equal to negative 641. Now then after that, like terms on one side. Now lattice energy of magnesium chloride is equal to negative 641 minus when this term crosses the equal sign, its sign changes. It becomes negative 1848. This is equal to This is equal to 2,489. This is the negative value. Now, we have determined the lattice energy, but as I have, this is kilojoules per mole, but as I have told you earlier that the lattice energy, but a sum of the bond energies is equal to lattice energy, but they are equal in magnitude, but opposite in sign. This is negative, this is the positive. So sum of the bond energies is equal. Sum of the bond energies is equal to the absolute value of lattice energy. Now, lattice energy is negative 2,489 kilojoules per mole. Then, after opening, then this is equal to negative. In order to obtain a positive value, we have to open the bracket sign by putting negative outside the bracket. Outside the bracket, I mean. Now this is 2,489. 9. Now negative cancel out. This is the positive 24,889. This is the kilojoules per mole. Kilojoules per mole. Now this is the total or sum of the bond energies in magnesium chloride. But in magnesium chloride, in magnesium chloride, there are two magnesium, 2 chlorine bonds. But there are 2 magnesium to chlorine bonds. To chlorine bonds. That is chlorine, magnesium, chlorine. There are 2 magnesium to chlorine bonds. So then 2 magnesium to chlorine, 2 magnesium to chlorine bonds. This is equal to the sum of the bond energies. Is equal to the sum of the bond energies. So this is equal to positive 2,489. This is kilojoules per mole. 2 bracket magnesium to chlorine bond divided by 2 both sides. Divided by 2 both sides. We will have a 1 positive 1 2 4.5. This is kilojoules per mole. Now, hence, magnesium to chlorine bond energy in magnesium chloride. Magnesium chloride is positive 1, 2, 4.5 kilojoules per mole.